Hello, everyone. Welcome back, and I'm really glad to see you here for the second part of our workshop. In our last season, we already covered the basics of RAG, retrieval augmented generation. So we compared it to a large context window, and we looked at some simple examples how AI can read the documents, and we also try to build AI agent based on this. But today we are going to go deeper. We are going to look under the hood to understand how machines can understand relations. We will talk about the engine of modern AI memory. So today's session is about vector databases and RAG. Let's start. Let's start from a quick recap from our previous workshop. So we discussed why LLMs are powerful but not enough on their own. As a reminder, they suffer from three big limitations. The first one is knowledge cutoff. They are frozen in time and stuck in the past. The second problem is hallucinations. When they don't know the answer, they make one up. And the last problem is private context. Public models don't know about your company and don't know your secrets or documents. They just hallucinate in this time. We also introduced a solution. The solution was RAG, retrieval augmented generation. Just to refresh your memory, RAG is basically adding a search engine to AI. Instead of relying only on the model's training, the process is to, first of all, to search the right information in your data, and then retrieve the documents, and then augmentation, or augment the prompt with the context, and then generate the answer. This ensures that AI speaks in facts from facts. Now let's talk about the vector databases and what is the difference from a normal databases. Traditional databases search for keywords. If you type, let's say, car, but the text says auto, you might miss it. But vector databases search for meaning. For AI agent, this database acts like a memory. And the magic, how does a computer understand meaning? It uses vector embedding. So look at this graph, and words become points, as you can see here. The computer sees that car, for example, and truck are mathematically close. They belong to one group, transport group, and on another side, let's say home or apartment or house, are in a different group, in house group. We call this semantic proximity. Things with similar meaning sit close together in a vector database. How do we actually create those vectors? We use a special tool called embedding models. Think of it like a universal translator or a dictionary. Then the good news is that you don't need to build it yourself. Almost every modern AI provider like OpenAI or Google or Facebook offers this as a service. So also there are a lot of free open source models, and you can run it in your machine. For example, for us developers, it is very simple. We just send a text, and this model sent us back the embeddings. But under the hood, the model performs three steps. The first step is tokenization. It breaks the text into small pieces, tokens, the name of those pieces are. Then ID assignment. It gives each piece a unique ID from a dictionary. And the last step is vector generation. It turns those numbers into a list of numbers. The list of numbers, this is a coordinate. This is a vector of our text. And this is a meaning of your text. Now, let's talk about a search, how it works. So, when user asks some question, we turn a user question to a vector, a text from a user to a vector. Then we measures the angle between a query, a user vector, and a document, a vectors from a database. And the rule is that smaller angle equal more similar meaning. This allows us to find the right answer among millions of files instantly. To make it work for your business, we build a pipeline. First of all, we should collect all information. So we take your PDFs, HTMLs, or any other documents where you store data. Then it is chunking. We chop them into small pieces, about 200, 500 words in one chunk. This is important because we don't want to overload the AI, and also different embedding models have different limits. Then the next step is factorizations. We turn those chunks into numbers, vectors, and the last step is indexing. We save all of them in database, and now all of your information, it is structured and searchable. Here is a small example. After the presentation, I will show you a real example of this agent. So this is like a perfect case. A user asks what is the company policy on remote work, and our agent can answer because the answer is clearly written in one place. As you can see, we found like a few different places, but the answer is clearly in one place. As a result, the agent can answer very correctly. And here is a bad example, the limitations of simple RAG. By the way, simple RAG is a name of RAG with a vector database. So I hope you know who is Tom Riddle. This is one of the person of Harry Potter movie. And as you can see in this example, if we ask AI who is Tom Riddle, we just have a simple answer that this is some student from Hogwarts, and that's all. The problem is that if, for example, if we ask, if one page says that Tom Riddle is a student and another page says that Voldemort was once a student, a simple search might not connect the dots. We call this relational blindness. The AI misses the hidden connections. And here is the fix for this. To fix those problems, we use advanced tools. The first one is GraphRag. So we can build a graph database, or it can be a hybrid search. This combines meaning search and keyword search together for the best results, and also re-ranking. This is a final quality check before the answer, but we'll talk more about this in the next workshop. So please register for it. And to summarize the presentation, RAG gives LLM access to your private data. Vectors let us search by intent, not just words. Chunking is the most important step for accuracy. For complex data, we need advanced RAG. And remember, the quality of your AI depends on the structure of your data. And the next slide is the final slide. Theory is good, but better is to see everything in action. So now we are going to move to the live demo. We will look at two examples that shows exactly what we just discussed. The first one example is a company AI agent. It will be AI agent who knows everything about company. And the second example is for Harry Potter fans. So here is a link you can download and try yourself everything what I'll show you right now. And now I will switch the monitor. One moment. Here is. So here is the code and the examples. I hope you see my code, right? Okay. So the first one. To start, I generated the company policy for a company. The company name is AI Company, and here is some long list of company policies. So we have here information about meetings, equipment, securities, dress code, some health insurance, bonuses, salary, and all of that. First of all, what we have to do is we need to make chunking of this text. Here is the simple Python code to chunk the text. So what we do, we just take the file, the txt file, and we split it based on sections. Section 1, Section 2, Section 3. So here you can see the code, nothing special. We just split the code and we save all of this into files. Here is already chunks, so we can see how it looks. Chunk one, section 1, so it's chunk 1, section 2, chunk 2. Here is all of the text of section 2. So we see 2.1, 2.2, and all of them. After that, what we need to do is to make vectors. And how it works. So here you can see the code, how we make vectors from chunks. We are using OpenAI text embedding 3 small model for this. It's paid model, but it's not so expensive. Um, and here is the example how it works. So here in the code we have we are doing we take chunks, we build vectors, and after that we save vectors in a database already. For a database, we are using Supabase. Supabase, this is like a mix of Postgres and vector database. So it is enough for us for a demo, and it is very easy to use because this is a cloud service. So as you can see, when we run, mm, I can run it. I can remove everything from our database. And now I can run injection. So as I said, we built a vector and we save a vector in a database using OpenAI embedding model. So we successfully imported 13 chunks. Here is a database, so we can see how it looks. Section 0, 1, 2, 3, and here is embeddings. As I told you previously, this is like a long list of some numbers. And now I will show you a live demo. So we have two Python scripts. First one is just AI agent, LangChain agent without a rack. So this will be this Python script will generate the answer based on what LLM model already knows. And by the way, we are using GPT-4o mini model. This is like a very cheap and small model. Uh, so we run the first example, and here I will run the second example, and we will ask the same question. The second example is the same agent, but with a rack. How it works, here is we have agent, the same model, but already we have few tools. For tools, search policy, get section by number, get policy stats, and get today date. We have some system prompt, and this one this one function is to search policy in vector database. And what we have a parameter query where we have what user asks, and what we do, we generate embedding. We get from a Supabase result based on based on these embeddings. So we can pass a threshold and we can ask how many results we need. Nothing special. So let's ask some questions. I prepared already a few questions, and let's say, I don't know, let's say about passwords. The first example, second example. As you can see, the first example without our vector database just answered something very general, like typically password requirements in company are and some rules for them. But if we check the second example, here we have a clear and correct answer from our policy. So the password requirements at AI company are with next rules, and I can validate this to show you how it works. Let's try to find. Yeah. So here in policies, we have that password should be minimum 12 characters. We have the same here. Enable two-factor authentications. So we have also the same rule here. Should be a mix of case numbers and symbols. We have the same rule here. So as you can see, the agent used information from other policy and generate the answer based on this. And here I can show you how it works under the hood. When we ask a second example with a RAG, our question, what is the password? What are the password requirements? So AI decided to use a tool search policy. The vector database, the Supabase, answered with first with the section 5 similarity is here. Then and based on this information, the AI already generated a correct answer for us. And here is an example without AI. So as you can see, without the RAG, as you can see, the question is what is the password requirements, and the answer is just from a knowledge of LLM, nothing special. Yeah, so this was a first example. As I told you, like a perfect example where everything works as it has to be. But I prepared the second example where we will see limitations of simple RAG. And now let's move to a second example. One moment. The second example is more complex and should be interesting for Harry Potter fans. We are going to build AI agent that knows everything about Harry Potter first Harry Potter movie. So for the data, I found in the internet the script of first movie. It is said in the text files, in one text file. It contains every scene, every action, and every line of dialogue, and who is saying what. So we can see everything what is happening in the movie. So the process is the same. We first of all we need to build to do chunking. To do chunking, here we have almost the same file to chunk by scene. Here we have, as you can see, scene 1, then we have scene 2, scene 3, and all of them. So what we do, we split the script based on scene, but also we have one more rule to check if we use too much words in a chunk. So right now we have 12,000 characters. Because I had a problem with the limit of this text tree embedding small model from OpenAI. So we split into chunks. To do that, we just need to run Python chunk text. And here we have already chunked file. So as you can see, we have sen1, sen2, sen3 with some metadata information. And the last sen, as you can see, is divided into 4 parts because it is too big to be in the one chunk. So after that, we need to create embeddings and save everything in our database. To do that, just run ingest, but I will skip it because we have too many chunks and it can take some times. I already did it before, so I can show you how it looks in our database. So as you can see here, we have our chunks with sense, we have a content, we have embeddings, and we have metadata information. So, and now what is interesting, we can run the example. As usual, we have two scripts. First one is without. First one is without a rack, and second one is with a rack. I can show you very fast. So here, as you can see, we have also the agent, the GPT-4o mini with some system prompts that you are very clever in Harry Potter movie and you know everything, blah, 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 guidelines, what to do. So simple agent. And second example is also agent, also for Omini with almost the same system prompt. So even we have less guidelines here, but we already have tools. The first one tool is to search something in screenplay. The second tool is to get the full stand by number. The third is get statistics about what we have in our database and get to the dates. We can skip it. So it works in the same way. We pass the user prompt here. We create and generate embedding from a query. And after that, we ask Supabase to select everything that is with the same meaning to us. I see the question about the chunks, so I will answer. Does the chunks has to be the same size? Also, is there a way to get chunks in a dynamic way without much knowing about separate chunks? So chunks can be different size, doesn't matter. But as I said, we have some limitations from embedding database, from embedding a model. So each embedding model has different limitations, and we also like it is very important to split chunks based on some scene or dialogues or something like that. But yeah, it is not critical to be one size or one scene. We can split one scene into a few chunks. It's okay for us. But better is not to split like one sentence into two chunks because AI cannot understand like the full meaning of the full sentence. So let's continue with our example. Here is, you can see the first example, the first script without a rack. I prepared also a few questions. And let's say we ask our AI, what is Dumbledore's first line in the movie? And here you can see that AI, based on the knowledge of this 4O mini model, answers that Dumbledore's uh, first word is "Good evening, Harry." Oh no, Harry Potter, you have your mother eyes. Yeah. But if we ask our rug example, we see that answer is, I should know that you would be here, Professor McGonagall. And now let's check where is it true. Here is the screenplay, scene 1, and the first Dumbledore dialogue is, I should know that you would be here, Professor McGonagall. So you can see that our rag example is better. And here I can show you how it works under the hood. So the first example, very simple. We just asked something and AI just provided some answer, nothing special. And the second example, we asked the Dumbledore's first line. The AI decided to use search screenplay tool with a query Dumbledore first line. The answer from vector database was scene 11, scene 1, scene 4, and as you can see here we have similarity. And scene 12, because we asked a vector database to return us 5 best results. And after that, with all of this information, our AI read all of this and answered us a best result with the best result. So as you can see, the LLM is really powerful. The LLM understands that we don't need to use scene 11, but we need to use scene first. And from a scene first, LLM took the Dumbledore dialogue and provided to us. I can run one more example. And after that, I know. Let's say this one. Did Harry mention Severus in the movie? As you can see here, in the first example, we have something very general that, yes, Harry mentioned Severus somewhere in the movie and blah, 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 nothing special. But in our example, you can see that assistant checked the database, and based on the answer from vector database, we have really a nice answer that in scene 12, the name of the scene is Sorting Hat. Harry is being sorted into houses. He notices Snape giving him sinister look. So we have really a nice answer. And And I can show you also a bad example, bad results, where we will see limitations of a vector database. As I said previously, limitations are relations. So when we use a vector database, we don't know relations, connections of all our entities. So as a result, for example, we cannot answer on a question like how many times did Harry call wrong? Because how it works. So when we asked our AI how many times did Harry call wrong, this one. One moment, I will find to show you. Severus. Yeah, here we have. So how many times did Harry call wrong? Our AI decided again to search in screenplay in our vector database using a query Harry calling wrong. As a result, we have approximately 5 cents because we limited our vector database to return us only 5 results. And as a result, AI based on those 5 cents provided us really bad answer. So we don't know, AI don't know, AI don't know the full picture, only 5 cents. And as a result, we don't know the exact number of the exact number how many times Harry called wrong. That's all from my side. If you have some questions or if you want to ask something our agent, I can try and show you. So go ahead and ask some questions. Thank you for your time, by the way. Here is the QR code of example. So you can try on your own machine to run everything. Can you run, so we have a question, can you recommend specific models for a cybersecurity use case? It's a very hard question. All AI providers are talking that everything is safe, but for sure, better is to use a local, to use your own instance and run everything on your own machine. So in the internet, you can find a lot of different models, embedding models. It depends of what language you want to use and what kind of I don't know how to say. Is it your text simple or very specific? Let's say if you are, I don't know, if you have some specific information about doctors, about some problems, or I don't know, about some rockets and space and all of that. So you need to use a really big embedding model. And the same example is with a language. If you want to vectorize, let's say, not English, but I don't know what to say, Ukrainian language, yeah. So you need to use a bigger embedding model. So it depends from a use case. I hope that I answered your question. The next question is, also you have compared multiple vector DBs, which one you might recommend? Um, the number one is uh, so yeah, I showed you a super base. It's like a very nice, database for uh, it's like a mix of Postgres and vectors. As a result, you don't need to have two databases. You can save everything in one place. It's easier, it's cheaper, and all of this. Also, you can run a Supabase on your own server, so it's also a nice option. But if we are talking about like big, something really big, when you have really a lot of vectors, better is to use a special database for that. So one of possible solutions uh, one moment, I will open some browser. It can be Qdrant. This is like uh, I would say the best option, but it also depends from a use case. Uh, Now I don't know where is yeah, I'm here. I stopped the sharing, right? Here is a Qdrant. I hope you see it. Yeah. Yeah. Perfect. So any other questions? Or maybe you want to ask something our AI agent? Maybe we have Harry Potter fans here. Okay. No, we don't have questions. So thank you very much for your time and have a nice evening. Goodbye. See you next time.